Hello, everybody. Welcome back to Clitop Engineering Urban Lectures Mechanics subject. My name is Damien Tyke, and today we will look at free falling motion of an object. And at the end of this video, you will be able to see free falling motion, basically the validity of the model for the free fall, and also you work out some of the uh, quantities in the free fall. But now, before we move to the free fall, let's just try and review some of the key points from the previous lecture. So in the previous lecture, we tried to look at three different kinds of motion. The first one is constant speed. Now, of course, this means the velocity of speed is constant and the acceleration is zero. And we also look at the accelerating motion. So if your object is accelerating, the direction of acceleration is always the same with that of the velocity. And we also look at the decelerating motion last week. So if you look at decelerating motion, the direction of acceleration is always opposite to that of the velocity. Right. So those are just three main points from the previous video, and today we are looking at the free falling motion. And now if you look at the free fall of an object, of course, free falling motion later you will see is where we just the constant acceleration motion. Right, so let's first try to prove that free falling motion is the constant acceleration motion. So let's just have the particle here, and let's say this is the surface of the earth, the ground. So particle is somewhere above the ground, and now particle is falling freely to the earth's surface. And when we say free fall, there are some assumptions that we have to understand. And the first one is other external forces on the object will be neglected. Right. So the first requirement is your object is just falling freely due to the pull of the gravitational acceleration to the ground. Uh, Other than the gravitational acceleration, there should be no other external forces. So even though they exist, they must be small enough to be neglected. And the main force, the main external force, when the object falls from some height to the ground is air resistance. And of course, if your object is small enough and if it's not windy enough, the air resistance can be neglected. But remember, if your object size is quite large enough, the area can be high, and then the resistance uh, from the air or aerodynamic forces cannot be neglected. And in this case, you have to use a full set of Newton's second law to derive the uh, acceleration. But for the time being, since we are learning free falling motion, we just assume that there's no air resistance, or even there's resistance, it's small enough to be neglected. And now we want to determine what kind of motion is the free fall. So, and of course, for this, we will always use the Newton's second law of motion to check types of motion of the object. So, Newton's second law of motion is just the net force or residual force on the object is mass times acceleration. So we have to find all the forces acting on the body, on the object, and then insert in this equation. So if your object free falling, you have neglected all the external forces. So there is the only force, which is just the pull by the gravity. And of course, from your O level, you know it's just the weight of the object. It just equals to mg. And now, for the sign convention, we will just take vertically downward as the positive. And if you question, can I take vertically upward as positive? Of course, it's totally fine. As long as your sign convention is consistent, you can use either direction as positive. But for me, for the time being, we just take vertically downward as positive because the direction of the motion of the object. And now if you look at forces acting in the system, we have only the pull from the gravity, which is just the weight. So we just substitute weight in the force. And on the left side, there's nothing changes. And the weight, of course, is just mg. So mg is equal to ma. And m appears on both sides of the equation. So you just cancel out m from the equation, and you will get a equals to g. And now, if you look at this, if your object is falling freely to the surface of the earth, under the only effect of gravitational pull, the acceleration of the object will be just equals to acceleration due to gravity. And now, of course, if your object is falling vertically downward, this means the direction of the velocity, your object velocity will be just vertically downward as well. So from the first video, we can easily link. Now the acceleration direction is vertically downward because equals to acceleration due to gravity, and the direction of the velocity is also vertically downward. Since the acceleration and velocity are in the same direction, the object is in fact speeding up or accelerating. And apart from that, acceleration is just equals to g. And of course, everybody's know here that g is just a constant, which is just 9.8 meter per second square. It's acceleration due to gravity. And now, that is the reason, if you look at free falling of an object, it's accelerating motion because the velocity and acceleration are in the same direction. And apart from that, the acceleration is just equals to acceleration due to gravity, which is a constant value 9.8. And that is the reason we can now conclude the free falling, if your object is falling freely under the influence of only gravitational pull, if air resistance can be neglected, is called the free fall, and its acceleration is constant, and the motion, the type of motion for the free fall is just constant acceleration. All right, so just remember those important points. So I will repeat myself. If the object is falling freely to the earth's surface, air resistance can be neglected, and there's the only force, which is the gravitational pull, the weight of the object, and the acceleration of your object is vertically downward and is constant and is equals to acceleration due to gravity at 9.8 meter per second square. Right, now we have determined the type of acceleration of free fall is constant acceleration, and that's the reason let's try to look at some of the equation for constant acceleration. So if you look at constant acceleration, we can just trace our equation for the acceleration, which is just v2 minus v1 divided by t2 minus t1. So at time t equal to 0, your object, let's say initial velocity is u. At time t is equal to t second, the final velocity is just v. And now in the acceleration equation, we can substitute v, which is the final velocity, in place of v2, and u, which is just the initial velocity, in place of v1, and t2 is just time t, initial time is just 0. And from that equation, you can get your acceleration is just final velocity minus initial velocity divided by time. And this is the formula for finding acceleration in a constant uh, acceleration motion. And of course, based on this equation, we can also try to derive the formula for final velocity. So let's try to play around. So a t will be just v minus u, and now v will be just u plus a t. And of course, this equation is the formula to find the final velocity if we know the initial velocity and the constant acceleration and the time. So Now we have two set of equation. The first equation for finding constant acceleration if we know the initial and final velocities and the time, or if we know the acceleration and time and the initial velocity, we can find the final velocity using v is equal to u plus at. So please have those equations in mind, and now we will link it to our free falling motion. So let's try and have a look at this. Let's say you have an object whose mass is m, and then the object is falling freely to the ground. And let's say the object initial velocity is just u is equal to 0. And of course, we know at any time t, your object velocity will be just v. And since it is free falling, if we neglect air resistance, then the acceleration of the object is just constant and is equal to acceleration due to gravity. And now let's try to get the expression for the final velocity, which is just v equals to u plus t. So you will have v equals to initial velocity plus a t. And now if your initial velocity is 0, you have final velocity v and a t. And of course, acceleration is just equals to acceleration due to gravity. And now you can easily see the final velocity for the free falling object is just v is equal to gt if the initial velocity is 0. And from that, we can easily see your object speeding up, and of course, uh, because it's constant accelerating, the velocity or speed must increase with the time. Apart from that, we know uh, the velocity is directly proportional to the time. So this means the longer the time, the higher the velocity. So this means the lower the object or the nearer the object to the ground, the higher the speed or the velocity is. And of course, we can obviously see uh, when the object hits the ground, and this will be the maximum speed because this is the maximum time that the object has traveled to the ground. So uh, when you have an object which is falling freely from certain height to the surface of the earth, uh, you will have maximum speed when it hits the ground. And now let's try to compare two cases. Let's say you have two objects of different masses. So you see object M1 has mass M1, object 2 has mass M2. And let's say M2 is larger than M1. And now let's say this is the surface of the earth, and they are at the same height initially, and both the initial velocity are just 0. So this means u1 is also 0 and u2 is also 0. And now let's say it's a certain time the velocity is v1 here and the velocity is v2 here. Now, if you compare the motion of the two objects, even though they have the same masses, as we have discussed earlier, for constant acceleration, the effect of mass can be neglected. This means the mass does not affect the velocity of the object or the speed of the object. And now you can easily see our final velocity v is u plus gt. And since u is initial velocity u is 0 for both objects, let's say v1 is equal to just gt1, and v2 will be just gt2. Now you can see here initial height of the objects are the same, so this means they have to travel the same distance, and they are just moving with constant speed. Constant acceleration. So this means, uh, regardless of the mass, the rate or increase of velocity or speed will be the same for both objects because they are from the same height, they travel from the same distance, and they reach the surface of the earth at the same time. So this means v1 and v2 will be the same at any time, at anywhere along the path from initial height to the ground. So this means when you have free fall free falling objects, there's no effect from the masses. Even though they have different masses, they will take the same time to reach to the ground, and at any point, any time, along their path of motion, the two speeds will be just the same. Right, so please remember, of course, here we just neglect the effect of air resistance because it's free falling motion. But if we do have air resistance, uh, the two uh, objects may not have the same speed at the same time. But this is, of course, the case with air resistance. Now let's try to look at another example. So let's say we have two objects of the same mass. So this is M1, and this is M2. Let's say M1 is just equals to M2, so they have the same masses. Again, this is the surface of the earth, the ground, and object M1 is initially height h1, object M2 is initially height h2. Both the object has initial speed of 0, u1 is 0, and u2 is 0 at time t equals 0. And of course, at a certain time, this object will have velocity v1, this object will have velocity v2. And now let's try to apply the equation of free fall for to these two objects. And now the free fall equation is just v is equal to u plus gt. So for object v1, u1 is just 0, so you will have just gt1. And for object 2, you will have just v2 is equal to gt2. And now, since the two objects are at a different heights, different location, you can easily see the two speeds of velocity would not be the same even at the same time because they are at different height. And now let's try to look at what happens when the object hit the ground. So this means when object reach that location, let's say how much will be v1 compared to v2. So we are interested in that. Now you can clearly see object 2 has to travel longer distance, but both objects experience the same amount of acceleration, which is just g for both objects. So the rate of increase in the speed is just the same for both objects, but for object 2 is located in the higher level compared to the object 1. So this means uh, h2 is higher than h1. So this means when they hit the ground, time t2 will be greater than t1. So this means object 2 take longer time compared to object 1 to reach the ground. So when they hit the ground, because object 2 take longer time, from this equation you can easily see that the velocity v2 has to be definitely greater than v1. So what does it mean? So it means that if the if you have two objects, in fact they can have same mass or different masses, it doesn't matter because mass does not affect. But if one object is located higher than the another object, it has to travel longer distance. So this means it takes longer time, and that is the reason when they hit the ground. If you compare the speed when they hit the ground, the object with initial higher initial location will have higher speed when they hit the ground. Right. So I hope you got those 2 points. And now we will have a small quiz, but before we answer the quiz, let's just try to look at the free falling motion. So free falling motion is just constant acceleration, and constant acceleration just equals to acceleration due to gravity is vertically downward, both the velocity and the acceleration. And there are two equations that you can use, which is if you want to find the constant acceleration, which is just v minus u divided by t, or the final velocity is just v is equal to u plus at. But for free falling objects, your acceleration just equals to g, so you can just find using v is equal to u plus gt. And for free falling, air resistance has to be neglected, and the effort of mass can be neglected as well. So if you have two objects with different masses, but as long as they are released from the same height, the time taken to reach the ground are just the same. So this means everywhere the velocity every time will be just the same because the rate of change of speed is just constant and the mass does not affect for both objects. So the rate of change of velocity will be just the same. So at any time, any point, they will have the same speed. But if you release two objects at different height, the object whose initial location is higher than the other object will have higher speed when they hit the ground because it takes longer time. Alright, so now if you understand this, let's try to just check your understanding with a small quiz. So uh, there are four balls with different masses and they are dropped from the heights shown in the figure. And air resistance can be neglected, and of course this means your object can be molded as the free falling object. And the question is which ball has the highest speed when it hits the ground? And you can easily see even though they have different masses, the effect of mass can be neglected. This is very straightforward. But of course, the effect of height is plays really important role. And as we have said earlier, the higher the object is, the higher the speed when it hits the ground. And of course, this means the object whose initial position is the highest will have the highest speed when it hits the ground. So the correct answer has to be D. Alright, I hope you got those points clearly. And in the next video, we will study uh, the object which is thrown against the gravity, so opposite to the motion that we discussed. So please subscribe to our channel and see you in the next video.